Now it's time to talk about the dark side of the universe. You see, all the matter that we've talked about till now, all the stars and the galaxies that we can observe, are thought to make up only about 4% of the total stuff that's in the universe. So what's the rest? Astronomers began to notice that clusters of galaxies were rotating too fast to be held together by their own gravity. They were spinning at such a rate that their mass wouldn't keep them together. They should be going flying off into outer space, but they don't. So they postulated there must be some sort of dark matter that we can't see, that's giving it this extra mass, that's holding the galaxies together. So what could this be? Well, scientists don't really know at this point, but a few theories have been put forward. That dark matter is either a MACHO or a WIMP. Now, a MACHO stands for Massive Compact Halo Object. Essentially, some normal type of matter, but one that we can't see. So for instance, a planet or an asteroid or even a black hole. Some sort of really large clump of matter that can't be detected by telescopes. And maybe this is what's causing all the extra mass. But could that really cause far more mass than the normal stars? Normal stars are thought to be 4% of the matter of all the stuff that's in the universe, whereas this dark matter is thought to be about 22%. Is there really that much planet asteroid material? Well, in fact, careful calculations about the density of the universe around the time of the Big Bang show that this couldn't be the case. So dark matter probably isn't a MACHO. So it is a WIMP. Well, WIMP stands for a weakly interacting massive particle. So if you remember, we talked about the neutrino. This particle that passes through us all the time, that doesn't interact, that doesn't affect us very much. Although we did say it has some important effects in things like supernovas. What we need is a particle like the neutrino, but much larger. The neutrino is very small. So we need a large particle, but that one that still doesn't interact much with matter. And so maybe this is what dark matter is. And there are a number of possibilities. Some of those crazy particles turned up in particle accelerators. But at this point, scientists have no clue what it actually is. But even that isn't the whole picture. Scientists began to realize that the universe is expanding at an accelerating rate. The universe is expanding faster and faster all the time. And there's this strange force of anti-gravity, you could say, that seems to be pushing the universe apart at an ever-increasing rate. They term this substance dark energy, and it's not known what it is, what it could be. It's almost like it's like intrinsic to space itself, but it's really important. So normal matter makes up about 4% of all the stuff in the universe. Dark matter about 22%. But the whole other 74% is this dark energy stuff. Now we have no clue what it actually is. But it's of vital importance because how much dark energy there is and what exactly it's doing will determine if one day the universe will go on expanding forever or whether it'll come back in a big crunch, and what that exact nature is in the end of our universe. So again, we see that the universe is far more mysterious than we thought. For all we know about stars and galaxies, there's only a tiny fraction. There's still a lot of interesting questions left to wrestle with.